All right, so now we're going to look at some examples involving simplifying by factoring and expanding. All right, so we're going to look at simplifying by factoring. So in example A, we have the expression 2 sine squared x minus 3 sine x plus 1, and we want to factor completely. So remember, anytime you see this sine squared x notation, that just means that we're squaring the entire trig function. This is sine of x all squared minus 3 sine of x plus 1. So looking at this expression, this reminds me a lot of just a regular quadratic expression. So if I had 2x squared minus 3x plus 1, and if I were to factor that, I know that I just need to find two numbers that multiply to a times c, which is 2, and add to negative 3. So those two numbers that multiply to 2 and add to negative 3 are negative 2 and negative 1. So I'm going to use that to break up my middle term. I'm going to factor this by grouping. So I'm going to have 2x squared and then minus 2x minus 1x, because that gives me the negative 3x, and then plus 1. And so factoring this by grouping, I'm going to get 2x times x minus 1 for the first group, and then when I factor out a negative 1 from the second group, I'm going to get negative 1 times x minus 1. My factors here match, so I'm in good shape. So this is going to factor as 2x minus 1 times x minus 1. So now looking at my expression here, I know that instead of x, we have a sine x. So I can just write my expression as 2 times the sine of x minus 1 times the sine of x minus 1. And that would be my factored expression. And to check this, I could just multiply everything out, and I would get my trinomial that we started with. All right, problem B, I have 16 minus secant squared x. So again, I'm thinking of this as 16 minus that secant x is being squared. So this reminds me a lot of my difference of squares form. So if I had 16 minus x squared, and we know difference of squares, a squared minus b squared, factors as a plus b times a minus b. So this is going to factor as 4 minus x times 4 plus x. Well, instead of x, we have secant x. So we're just going to go ahead and factor this as a difference of squares. So we have 4 minus secant x times 4 plus secant x. All right, now for C, we have two terms here. I have cosecant alpha minus cosecant alpha times cosine squared alpha. Now, notice here, right, when we want to factor, we always want to check for a greatest common factor first. So I'm looking at my terms, and I notice that they both have a cosecant alpha in common. So what I can do is I can actually factor out cosecant alpha from both terms. So I'm going to factor out cosecant alpha. And when I do that, remember, when we're factoring, we're just pretty much dividing. So I'm just really dividing by cosecant alpha here from both terms. So when I do that, I'm left with 1 from the first term. And then I'm left with cosine squared alpha from the second term. Now we want to factor completely, right? And so again, I'm looking at my inner parentheses here, and I notice that's going to be 1 minus cosine alpha quantity squared, right? That's what that notation means. And again, this should remind us a lot of just 1 minus x squared. That's the difference of squares. So that's going to be 1 minus x times 1 plus x. Well, instead of x, what do we have? We have cosine of alpha. So I'm going to write my expression now as I still have my cosecant alpha as my greatest common factor. But now my parentheses is going to be 1 minus cosine of alpha times 1 plus cosine of alpha. And that will be considered factored completely. All right, now for D, Here I have three terms, but I notice that it's quadratic, but there are two separate trig functions. I have a cosecant squared beta and a cotangent beta. So I need to write this expression in terms of one trig function first, and then I'm going to factor. So rewrite in terms of one trig function. All right, so what am I going to do? Well, I noticed that I have a cotangent beta, and since that is not being squared, I probably want to go ahead and try to see if I can write this expression just in terms of cotangent, all right? So I'm looking at my cosecant squared beta, and I'm thinking, do I have an identity for that? Turns out I do, right? There's an identity that 1 plus cotangent squared equals cosecant squared, right? That's one of our Pythagorean identities. So I can write this as 1 plus cotangent squared of beta. And I have now minus cotangent beta minus 3. So now combining like terms, this is going to give me cotangent squared of beta for my first term, minus cotangent of beta, and then minus 2. Now all of my terms are in terms of cotangent. I have one trig function. I'm ready to rock. So this looks like a quadratic expression, right? So if I think about just the expression x squared minus x minus 2, but instead of x, we have cotangent. So x squared minus x minus 2, that's easy. I'm just going to factor that as x minus 2, x plus 1. So we're going to just replace x with cotangent beta. So this is going to be cotangent beta minus 2 times cotangent beta plus 1. So that'll be my fully factored form.